All right, this is chapter 4, number 44. It's a problem that reads, drag race tires in contact with asphalt surface have a very high coefficient of static friction. Assuming a constant acceleration and no slipping of the tires, estimate the coefficient of static friction needed for a drag racer to cover 1 kilometer in 12 seconds starting from rest. So this is again is a blend of what we know about unbalanced forces and kinematics. Okay, so some things that I'm aware of at this point. It's got to cover a kilometer, so it's 1,000 meters. You have to do it in 12 seconds, and the car has an initial velocity of 0, so it's at rest. Okay, now what I know is that if I'm going to cover that amount of distance, yeah, it has to be accelerating at some rate. So with delta x v naught t plus 1/2 at squared, I know that the v naught t goes away. You've got 1,000 equals 1/2 of a times 12 squared. So we get an acceleration of 13.9 meters per second squared. Okay. Now, in this particular case, they don't give you a mass. So I know a lot of people are thinking, all right, well, the sum of the forces, if that's supposed to equal ma, well, there's a problem because I don't know the mass. However, in this problem, it's the force of friction that allows you to accelerate. Therefore, the unbalanced force is the force of friction. And with this connection, I know that the sum of the forces is equal to ma, and I also know that the force of friction is equal to mu times f of n. And in this case, f of n, and if I draw a little free body diagram here for you, you'd have your f of n this way, and you'd have your f of g this way. Okay, f of g is equal to mg, and the car is not accelerating up or down, so the normal force is also mg. So I can replace that right there. And what that allows me to do is get rid of the mass. So I now know that the acceleration is equal to mu times g. So mu is a divided by g, which would be 13.9 divided by 9.8, and we end up with a mu value of 1.42. Reminder that mu is a unitless quantity. Okay. That's a pretty quick one actually, but again, it can be a bit of a troubling problem for some students. Okay.